Polynomials are functions that are powers of a particular unknown, frequently x or z. If we consider a function like 3x cubed plus x squared minus 4, we find that MATLAB represents this polynomial as a row vector of coefficients, starting at the highest order term down to the lowest. So this particular function would be 3, 1, 0, negative 4 as a row vector, with the first 3 representing 3 times x cubed, the 1 representing 1 times x squared, the 0 representing 0 times x, and the negative 4 representing negative 4 times the constant 1. If you consider the form of a polynomial, you'll see that it's a length n plus 1 array in the coefficients. This provides us a consistent way of talking about these in any format that we want to manipulate them. MATLAB very frequently represents polynomials in this way. Here we see some examples of MATLAB polynomials. For instance, x plus 1 is represented as row 1, 1, and so forth. Keep in mind that all of the 0 coefficients need to be included in this. For instance, x to the 6th includes a 1 as the multiplier on the x to the 6th, but needs to include 6 zeros afterwards to cover the other powers of x and the constant term. Representing polynomials this way is fine, but how can we use this vector representation practically? Polyval will be used to evaluate a polynomial in this format at a given point or an array of points. So for instance, my line is defined as x plus 1, 1, 1 in polynomial terms. Using polyval returns to us an ans of 2, evaluated at point 1. So x equals 1, so x plus 1 becomes 2. So polyval is going to be our tool for manipulating and plotting and drilling down into what's going on with these polynomials. So let's plot this across a number of points x. Here we have x as a linspace from 0 to 10 with 101 points. Y is evaluated as a polyval over that same line, x plus 1, over all points x. So you'll notice that the length of x is 1 by 101 double. Y is also 1 by 101 double. We create a new figure and we plot the data as a red line. This works for any order of polynomial. For instance, here we have a parabola, 2x squared plus x plus 1. We're going to evaluate it at the point 1, which generates this polyval, which gives us an ans of 4. We're also going to take a look at plotting it across the same range 0 to 10. We're going to plot that parabola with a red line again. This means that multiplying a polynomial is a little bit more complicated. Star and dot star won't do exactly what we want. So we have to use the convolution operator instead, conv. And here we see 3x squared minus 1 times 2x plus 5 multiplied together gives us 6x cubed plus 15x squared minus x minus 5.